Welcome to qnawire.
So for part A, we know that the initial charge, essentially, the initial positive charge on the outer surface of the conductor would be equal to the uniform surface charge density times the surface area. This is equaling sigma 4 pi r squared. And so this is going to be equaling 4 pi multiplied by the uniform surface charge density, 6.37 times 10 to the negative 6 coulombs per square meter, multiplied by the radius squared, 0.250 meters quantity squared, and we find that the initial charge is going to be equaling 5.00 times 10 to the negative 6 coulombs. Now, and a negative 0.500 microcoulomb charge is into the cavity. So now the outer charge is going to be equaling to, now it would be 5.00 microcoulombs minus 0.500 microcoulombs. This is giving us 4.50 microcoulombs. And so now the surface charge density is changed, and this would be the charge Q divided by the surface area. And so this would be equaling 4 pi multiplied by here, 0.250 meters quantity squared. And then for the numerator, 4.50 times 10 to the negative 6 coulombs. This is giving us 5.73 times 10 to the negative 6th coulombs per square meter. This would be our answer for part A. For part B, we're going to use Gauss, where here the electric field is equaling the electric flux divided by the area, area A, and so this is going to be equaling the charge divided by epsilon naught times A, and this is equaling the charge divided by epsilon naught times 4 pi r squared. And so we can then find the electric field by substituting for part B. This would be equaling, for the denominator, 8.85 times 10 to the negative 12th. This would be coulomb squared per Newton per meter squared. This would be multiplied by 4 pi r squared, so 0.250 meters quantity squared. And then for the numerator, we have 4.50 times 10 to the negative 6th coulombs. This is equaling 6.47 times 10 to the positive 5th newtons per coulomb. This would be your answer for part B. For part C now, to use Gauss's law to find the electric flux. So the electric flux is going to be equaling the total enclosed charge divided by epsilon naught. And so we can simply substitute. This would be equaling negative 0.500 times 10 to the negative 6th coulombs. This would be divided by epsilon naught, 8.85 times 10 to the negative 12th coulomb squared per Newton per meter squared. And so we find that the electric flux is equaling negative 5.65 times 10 to the 4th Newton meters squared per coulomb. This would be our final answer for part C and our final answer for part B. That is the end of the solution. Thank you